The title for this project is Advanced Deep Learning for Medical Imaging, Pneumonia Prediction and COVID-19 Detection. Our goal for this project was to develop a deep learning model capable of analyzing photos to classify individuals as having pneumonia, COVID-19, or being healthy. We will now introduce ourselves. My name is Fabiola Rivera Noriega, and I am the product owner and team lead.
And I'm Eduardo Suarez.
Hi, I'm Daniel Gutierrez.
Hey, I'm Ryan Pareda.
And I'm Justin Trewick.
Our motivation for this project stems from a deep passion for using advanced technology to improve healthcare outcomes, especially in underserved and impoverished regions. Diagnosing pneumonia and COVID-19 quickly and accurately is crucial, particularly in areas with limited access to medical resources and specialists. We acknowledge that sometimes diagnostic methods can be time-consuming and prone to error, especially under heavy workloads faced by healthcare professionals in such settings. By leveraging deep learning, we aim to provide a tool that can assist doctors in making faster, more reliable diagnoses, even in resource-constrained environments.
An artificial neural network, or neural network for short, is a machine learning model inspired by the way biological neural networks in the human brain process information. They're used in machine learning and AI to recognize patterns and make predictions based on data. A neural network is composed of neurons, which are the basic unit that process input data, similar to biological neurons. It's also made up of 3 layers, as you can see on the right: input, hidden, and output layers. The input layer takes the input features. The hidden layers are the intermediate layers where computations are performed, and the output layer produces the final output. We have different types of neural networks, but for our project, we decided to use convolutional neural networks.
All right, a convolutional neural network is structured in the way that a regular neural network is, as explained before, but with the inclusion of convolutional layers. These layers generate a filter of the image called a feature map by performing many convolution operations on it using matrices called kernels. During training, each kernel is made such that the feature map it generates represents a feature of the input to its layer that is relevant towards ultimately making an accurate prediction. A layer can have many kernels associated with it, and thus represent many different features of its input through the feature maps that they generate, which are then passed as input to deeper convolutional layers. These deeper layers will take all of the maps generated before it and use its own kernels to generate maps of its own based on the entirety of the information before it. In this way, the layers can be thought of as progressively compressing information such that the feature maps will represent higher level and abstract features like a head, a tooth, or the ocean. The maps at the deepest layers are ultimately what informs the final layer of their values, making a prediction for the model.
As mentioned before, we will use the power of deep learning through a convoluted neural network to be able to make diagnoses on certain medical imagery. The first dataset we will train the model on includes patient CT scans of both positive and negative cases of SARS-CoV-2, or colloquially known as COVID-19, that were all gathered from a publicly available hospital repository in Sao Paulo, Brazil. COVID-19, a coronavirus that targets the respiratory system, itself needs no introduction, as its wide-ranging implications on public health, the economy, and education have all affected us in some way ever since its first outbreak in 2020. These scans, like the ones shown on the right, where the top scan shows a positive test and the bottom shows a negative test, are first converted into image sensors, which you can think of as multidimensional numerical arrays, from which our model learns to identify critical visual indicators or features of COVID-19 in CT scans. These indicators include hazy opacities, which visualize inflammation, dense white areas, which indicate fluid buildup, and reticular lines, which suggest lung damage.
Pneumonia is a form of acute respiratory infection caused by viruses or bacteria, and it leads to mild to life-threatening illnesses in all ages. It's the largest infectious cause of death in children worldwide, killing over 808,000 children under 5 in 2017. These chest X-ray images were sourced from pediatric patients aged 1 to 5 years old at Guangzhou Women and Children's Medical Center. An example of these can be found to the right of the screen. These images were part of routine clinical care, and they underwent quality control to exclude low-quality or unreadable scans. The diagnoses were initially graded by 2 expert physicians, and then they were validated by a 3rd expert to ensure accuracy. As for our project, we're going to train, test, and validate our model with X-ray scans from both pneumonia patients and also healthy individuals. We'll convert these X-ray scans into image tensors, and our CNN model will use its feature classification layers to detect signs of pneumonia in the X-rays. And that's all for our project. Thank you.